Welcome back to the second part of the review from Math 140 here at FECC. And this last bit of review is on scientific notation. If you don't remember, we'll talk about it here real quickly. It's going to be quite useful for our class as we move forward. All right. So, what is scientific notation and why does it exist? The basic answer is that it's for representing very large and very small numbers. All right, so when you're talking about some probabilities that we'll see later, they may be very small. By small, we mean close to zero, right? We'll see it with when we're doing pH later. And then for bigger numbers as well, for instance, if you're looking at the distance to the sun and those sorts of things. The idea is to write a number with a single digit in the ones place, okay, followed by a decimal, and then multiplied by a power of 10, which tells you how many zeros there are, so to speak. All right, so for instance here, this first one is, okay, that's 2 million. And that is 2 times 10 to the 6th. Right? There's 6 zeros. It's a 2 times 10 to the 6th. Now, on the other hand, if we have 0.000002, that's 2 times 10 to the negative 6. And let's make sure we understand that as, okay, why is that? Let's see here. I'd have to go the decimal 1, 2, 3, 4, 5, and 6. Okay? That's where that 10 to the negative 6 comes from. All right. Now, let's see some examples here of scientific notation. We have Avogadro's number. All right, it's 6.02214 times 10 to the 24th atoms per molecule in 1 mole, an important unit for chemistry. And you here, notice we have this 0.02214. That this may not seem, these numbers in the decimal may not seem important, but remember, this is multiplied by 10 to the 24th. So these are actually represent very large numbers, those two added to the 6. It's okay. So they are important and they're good to put it on there when we need to. Diameter of the sun is 1.39 times 10 to the 6th kilometers, okay? So that is what? That's going to be 1,390,000 kilometers. The diameter of the Milky Way galaxy is approximately 9.99 times 10 to the 17th kilometers. Okay, we expect that to be bigger than the sun, right? The diameter of a hydrogen atom, now we're on the small side, the very small, and this is 1.2 times 10 to the negative 10th meters. Good. So those are some numbers. They come up. All right, it's a useful way for dealing with these large and small numbers. Let's do a little practice of arithmetic using scientific notation. All right, so here, let's see, 2 times 10 to the 6 times 6 times 10 to the negative 3rd. I think it's easiest to take advantage of the associative property here because don't mistake that with distributed. Notice why? This is all multiplication that we see here, all multiplication. So there's no addition involved for the distributive property, right? That distributive property was where multiplication and addition, how they mix. All right, so here we could simply say, okay, so this is 6 times 2. That is 12 times 10 to the 6th times 10 to the negative third. We've learned they're the same base, so we add the exponents and we get 10 to the third. Okay. Now, however, we want to put, for scientific notation, we only want one digit in the ones place. So in order to put it in real sign, this is going to be 1.2 times, okay, now you question, okay, is that 10 to the fourth or 10 squared? Well, think about it. We'd want that to be now it's 1.2 times 10, the number should go up there, 10 to the fourth. And I want you to consider that. Think about why that makes sense each time. Don't just try and follow the rules, try and understand the rules. It makes life a lot easier as we move on through the class. Okay, similarly, looks like I'm missing a parenthesis down there. By the way, is really a fraction line represents, there's an understood parentheses underneath. Okay, so here, this is, well, maybe we do the numerator first and we get 6 times, what do we get here? 10 to the correct 18th. Good. Hopefully we're able to see that. And we're still over 5 times 10 to the negative 3. Okay. Now we have to go obviously a bit further here, and let's off to the side first of all. 10 to the 18th over 10 to the negative 3rd. Right? What is that? What does that equal? Well, our formula says that's 10 to the 18th minus negative 3. And that becomes 10 to the 18 plus 3, 21. Okay, so we're going to write this as 6/5 times 10 to the 21. Good. All right. Last up is, what is 6 divided by 5? Let's see here. If my mental math works, 1.2. And that's times 10 to the 21st. Okay, and we could always check. Here I have Desmos there. Let's just check what we have. Let's see. Okay, so first, 6 divided by 5, 1.2. And if you're curious, how did I do it in my head? Well, 1/5 is 20%. 5 is 20% of 100, right? So that's how I get the 1.2, because that's 6/5 is 1 plus 1/5. Hopefully we see that right. 6/5 is 1. I'll write that down. 6/5. It's good to get used to fractions. Is equal to 1. That's 5/5, right? Plus 1/5. And that's how I get the 1.2 there. All right. But please use your calculator. I'm happy for you too. And let's just see here to make sure that we get these other one. Make sure seems correct. Is, let's see. Let's just do the first one. 2 times 10 to the 6 times 6 times 10 to the 6. Negative 3, sorry. Negative 3. Oh, well, is that what we had? Oh, yeah, we got a better check. In scientific notation, let's see, does that match the other side? 1.2 times 10 to the 4th is what we... What did I do there? Times 10 to the 4th. Oh, and good, those two match up. Did that correctly. So, that's some arithmetic with scientific notation. Again, it's quite a useful tool, and useful to understand. And I think I better say here is, Desmos doesn't do it, but if you're using your calculator, something like if you plugged in this second one into your calculator, you may get something that looks like this. 1.2 capital E 21. That means because in the calculator it's hard to have the numbers up in the exponent. So really what that means that is 1.2 times 10 to the 21. Now, please don't write this as your solution. I need you to I would like you to be able to see that that's what the calculator means when it spits that out. Okay, and that's scientific notation. I think we'll be ready. Next up is looking at some linear equations and learning how to think about them as functions. Okay, have a great day.